Hello everyone and welcome back to this video course on Java. I'm your host Trey, and today we're going to be talking about mathematical operations, strings, and characters. So without further ado, let's get into it. So mathematical operations, these are basic mathematical operations that you'd find, everywhere, like as the name suggests. But with this, like I talked about in the previous videos, we talked about the libraries that are found in the Java development kit. And those libraries, some of them include the java.util.math, right? And others are in the language, and others are in the math class, the math library themselves. So today we're going to talk about the math class, the mathematical class, sorry, and the string class. So let's begin with the math class. Okay, so with the math class in Java is part of the java.lang package and provides a set of methods for performing basic mathematical operations. These methods are static, meaning they are called directly on the class rather than the instant on the class. Here are some methods in the math class. Okay, so we have our class column there, we got a method column there, we got a description, syntax, and example on how to use that syntax. So we have a trigonometry class in the math class itself, and we have the sign, and this gets radian value. So whatever value that you have in radians, you place it in the parentheses there, and we have the sign method that executes that method. And the description says the sine of an angle in radians. So it gets the sine of an angle in radians, and then it does that. So let's just say our syntax here, we use math.sign, and the math is capitalized, capital M, by the way, there. So math.sign. So this math class, and then the dot operator is used to call upon the method that we are using. We'll talk about that in object-oriented programming later on, but right now we just have this math.sign value, and then our value here in radians, whatever value that you decide to put in radians, and your value is going to execute that in radians as well. So we have math.sign, and then we put in 0, and sine 0 on calculator is equal to 0. And then the same goes with cosine, and then the cosine of an angle, math.cosine value, and then we close our values there, and then we have example, which is cos 0, which is 1. If you put that on a calculator, you get 1. And then we have our tangent there, radians, and so on and so forth. Same thing as there, and if you put that in a calculator, you get that value. Then we have a 2 radians degree method. So this gets any value in degree, whatever degree value that you get, and it turns it to radians. So it returns a value of degree to radians, right? So every value that is of class degree, you get the output radian, right? So the syntax here is math.to radians. So when you want to change a value that is in degree to radians, you can use the math.to radians operator there, and then you put in your degree value that's there. So for example, you could say math.to radians 30, and 30 here, if you take it to radians, you get pi over 6, right? If you do your basic trigonometry, or if you remember, radians of 30 degrees is 0.5236 or pi over 6, depending on how well you did. And then we have the opposite, which is the 2 degree radians. And then it returns the value of radian to degree, and that's basically the opposite of the 2 radians method. And it says math.to degree radians, and then you could get math.pi divided by 2, which is equal to 90, because pi over 2 in radians is 90 degrees. So you get the picture. Alright, so we also have the exponent class, right? And it's basically, as it suggests, it uses the exponents. So here we have exponent x, and then returns Euler's constant to the power of x. So here we have the Euler's constant, which is 2.17 something. I'm not necessarily sure, but it gets the Euler's constant and gets sets it to the power of x. So how to invoke this method? You use the syntax math.exp, and you open the parentheses and say x, and you close that, and then you have an example here of math.exp1, and you get Euler's constant, which is just e. The same is for logarithms, and returns the logarithm of x. So basically ln x, right? The basic log of x. Or you could say log base e of x, whichever one you prefer. So just like that, if you do log 1 on your calculator, you will have 0. And you can call that using the math.log value there, right? That's the syntax. And then log base 10 of x returns the base 10 of log x. So if you have math.log 10x, um, that's the syntax there. And if you put math.log 10 for 100, you get 2, because 10 to the power 2 is basically 100. So base 10 of 100 is 2. And then you got the power method, a comma b, and it returns a value of a raised to the power b. And you can invoke that by using the syntax math.power a comma b, and then you close the instruction there, and then you have math.power, for example, let's just say math.power 2 comma 4, and it raised 2 to the power of 4, which is 16. Then we also have the square root function or square root method, sqrt x, which is our value there, and returns the square root of x for every x value that is greater than or equal to 0. Remember, the square root of 0 is basically 0, the square root of 1 is 1, and all positive values are acceptable in the square root, mathematically speaking, except for any negative number. So we have our syntax, which is math.sqrt, and you have x there, and then you close the instruction. And the basic example could be math.sqrt of 16, which is equal to 4. All right, so that's basic exponents, arithmetics within mathematical class, and we get to see the type of relationship that's there everywhere. And then we have the random class. I talked about it in the previous video, and now I'm just going to expand on it. So the random class is the random method. Sorry. Oh yeah, the random method. The random class has a random method, and this returns a double value that is greater than or equal to 0.0 and 1.0. So it gets any number between 0 and 1. So it's everything there. And if you want to get an actual value, let's just say an integer or a double within this range, actually basically just an integer, we are going to say, you're just going to declare the syntax using int. So we're going to narrow it down. We talked about narrowing the data types or explicit casting, and we're going to explicitly cast this method math.random, supposed to be m there, math.random, and then we open our parentheses there, and then we multiply it by any value a. So let's just say we want to get any number between 0 and 9. We're going to say int math.random, and then we're going to multiply it by 10. So when we invoke this method here and we use this syntax like this, it will generate any number between 0 and 9. So if you say math.random multiplied by 100, it will generate any number between 0 and 100, 0 and 99, sorry. So if you say 101 here, you are going to get a number between 0 and 100. So basically, we're talking about indexes here, starting from 0 all the way up to the number minus 1 that we're looking for. Okay, so here we have an example that uses mathematical operations. Basically, we're using the terminologies of finding the quadratic function or the quadratic equation, or basically finding the roots of a quadratic equation, basically, or finding the roots of x. So we import the java.util.scanner class there, and then we say public class roots, and then we have public static void main string, I guess we have our method there, and and then we create the object for the scanner class, right? So we have that there. So we have system.out.println. A quadratic equation has the format of a um, a multiplied by x to the power of 2 plus b multiplied by x plus c. This is the general format in the mathematical terms, and we are prompting the user to say, okay, so a quadratic equation has with this format, give me what a, b, and c is. So we are saying what is the value of a, and then here the user is going to put in the value of a. What is the value of b? The user is going to put in the value of b and c. So we put in double because we realize that any value of a here can be any number. It could be a fraction. It could be any value, so long as it's raised to the power, it's multiplied by x raised to the power of 2. That's what a quadratic equation is. So we're raising it to a double, and we're declaring it as a double. So we have a, b, and c. And then we verify the function here and say system.out.println. The function f of x is equal to a plus we concatenate this guy here. We get this guy a x to the power 2 plus b multiplied by x plus c, right? So these are a, b, and c values there. And then now we begin our calculations. We say double discriminant is equal to math to power b 2. So now here we have math to power. We're using our mathematical operations there to actually get to our power. So we raise b to the power 2, right? Because the formula has got that I don't know what to call it, but it has a discriminant where b is raised to the power 2 minus 4 multiplied by a multiplied by c, right? And we have that guy. So this is every value that is within the square root of the function. And we say double x1 is equals to negative b plus math of square root. And in that square root there, we put this discriminant value, the value that we get here, in the square root. So this discriminant becomes every value that is within the square root there, right? And then we use our augmented operators. We talked about them in the previous video. And then we say x1 divide by, our x1 value is going to be negative b plus math to square root discriminant divide by 2 multiplied by a, right? And we're going to say x1, our new value of x1 is going to be equal to the value that we get when we divide this value by this guy. So that's what we've done here. We've used a augmented operator there. And we do the same for b, but then, so we do the same for x2. And the difference is that rather than adding plus there, we're going to subtract it from that guy. And we're going to say x2 divide by this value here. And then we have our print line method now, which says the value of x is either x1 or x2, right? So this is our program of finding the roots of an equation or the quadratic equation, and we can use that, and we can just have our output there, which is, so we call upon Java roots.java, and we have our output, which is going to be a quadratic equation has got the format of this guy. So we're doing this thing here, and then if we put in 1, 5, and 6, we have our function there: 1 x to the power 2, 5x 5x plus 6. So we see that this value here, this point here, is this um, print method. This is our output here. We have this guy here because we've put in 1, 5, and 6. So we've said 1 raised multiplied by x to the power 2 plus 5 multiplied by x plus 6, which is this exact statement here. And then as our calculations have been done, we see that the value of x is either negative 2 or negative 3. So if you want, you can verify this using your calculator, or you can mathematically solve it physically. You will get the same value. So this is basically an operation, or this is just code that uses some of the math classes that do all these exponent methods and whatnot. Alright, so with that being said, let's talk about the character class. And the char type is used to represent a single 16-bit Unicode character. This is intended to hold any data type that can hold any character. So it's basically almost like a wildcard, like the way strings are. But then with a character, you can literally name any character that is ever existed or that is there, that is in 16-bit Unicode. So computers use binary numbers, and a character is stored in a computer as ones and zeros. So therefore, mapping a character to its binary representation is called encoding. Just a few, just facts that I thought to add in there. Unicode is basically an encoding scheme that supports the interchange, processing, and display of written text in the words of diverse languages. So that's also another interesting fact that you should know. If you're ever to be asked what encoding is, you would just tell them this definition there. Okay, so we have the character class, and this class basically we have methods that are used for returning some specified value or what we need. So we have our method column, we have our description column, and we have our examples in that sense. So first things first, we're going to start with the is digit method. So it returns true if the specified character is a digit. So we can just declare something and say char because my char or my character, which is equal to 6. So remember that we enclose these in single quotation marks, not double quotation marks, and then we put an if statement and say if my char is digit, and then we put the parentheses there, then our system the outer print line is digit. So it's going to return a digit that way. And we also have the is letter, right? It's the same as the is digit, but then it will return true if the specified character is a letter. So you can try to do that there. And then there's also this method that says is letter or digit and returns true if the specified character is a letter or a digit. So it will tell you, it will print out true, and then it will tell you if it's a letter or a digit. And then we have got the is lowercase, returns true if the specified letter is a lowercase, is uppercase, returns true if the specified character is uppercase. So we have these examples there. You can pause the screen, you can write this down. But we do have these two that do not have an example. I'll give you a practical example later on. But the two uppercase, this is in the character class, and it returns the uppercase of the specified character at that point. So here we also say to lowercase, same thing as uppercase, but you get the general idea. So we have strings, right? So we talked about strings a lot, and I'm pretty sure you're tired, but this string class is very, very important when it comes to Java and anything to do with strings. So the string class is a fundamental class that represents a sequence of numbers or characters, sorry. So here's a basic example. So we have string message, welcome to Java. In the terms of character, you could see it as this table. So we have welcome to Java. Notice that there are spaces here, right? So when it comes to index-wise, this entire message here has got 15 characters, starting from 0. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we have a space there. This space is also a character. This space is also a character. So everything that's in here is a character as well. So the character methods can be used in strings as well, but the strings methods cannot be used in characters. Like I said, the string method is a wildcard for some reason. I have no idea, but that's the way it was programmed. Okay, so we have our string classes there, and the methods that are in the string class are as follows. So we have the length method, and the description is it returns the number of characters in a string. So length is supposed to be lowercase. I made a typo there, so just make sure you correct that. So it returns the number of characters in a string. So everything that's here, right? If you were to say welcome to Java, if we were to put the length method, it would tell us that there are 15 characters in this. So we got the character at index value there, and then this returns the character at a specified index. So we have to uppercase, which returns a new string with all at uppercase. We have the to lowercase, which returns the string with all lowercase, and we've got substring, start index, the starting index that we want. So if we want our index to start at 1, it will return the string starting from that specific index. So the substring here method, where we got start and end index, returns a substring starting with the defined index and ending with the defined index as well. So here's a code that uses those methods that we've talked about. We're going to use the uppercase and the character at and the lowercase and the substring methods. So we import the java.util.scanner, and then we say strings code, and then we do our main method there. And then we create the object for the scanner. This is supposed to be a comment. I don't know why it's not. This is supposed to be a comment. So here we have create the object for the scanner. Then we've got scanner object equals to new scanner system.n. And then we have our print line method, which is say what is your name, and then we put in the constraints, which is first name and last name. So the user is going to say, oh, okay, put in your first name and last name. So we have string f name, which is object. So notice that this, I've declared this as an object so that you know that you can put in any value, any identifier as an object, so long as you use that object consistently, right? So this can be any value. It could be input, it could be object, it could even be your name. You can put it there, but so long as you put it and you use it everywhere for this kind of class. So we've got string f name, which is object.next, and we have string last name, which is object.next as well. So with that said, we say system.out.println welcome f name dot to uppercase dot character at 0. So with this method here, we've said that on first name, right, the first letter at the index 0, right, we are going to say put it to an uppercase. So I've told the compiler, say, hey, go to the first character at the f name and turn it to uppercase. So that's what we've done there. And then we concatenate this guy here, and we say f name dot to lowercase dot to substring. So substring starting at index 1. So from index 1 going all the way this side, so meaning the second character in your string, you're going to tell the Java compiler, say f name dot to lowercase. So turn everything from the second character all the way up to the last iteration of f name to lowercase, right? And the same can be said for last name. You uppercase the first character and lowercase the remaining characters. So here's our output, and if we were to say java dot strings strings code dot java, we could say that what is your first name and last name. So if I was to put my name in all caps, Trey Chella, you will notice that once this operation is done, we have welcome Trey Chella. So notice that this is in all caps, and this guy who is in um, all caps, we have the first letter which is capitalized here, and then we have the rest of the methods that are, or the rest of the string for f name, which is in lowercase. And same can be done for the second, for the last name there, we have capital letter C, and we have small letter Hella. So so this is just a basic representation on how to use the strings methods and everything that we have to do everything with the strings code. Alright, with that being said, this is your exercise for this video. Write a program that returns the number of characters in a string. So that's pretty easy to do. So just try to do that, and don't forget to have fun with code. Just be innovative, and that's basically the key to programming. So if you have an imagination, that's what helped me going, and I'm pretty sure that's gonna help you going as well. So next we're gonna talk about loops. So I will see you in the next video. Please like and subscribe this video and turn on the notification bell for next videos. And I will see you in the next video. Take care.